So in this question we are given that this is f of t is a periodic function with time period t, and the spikes are located at every half a second. Here you can see one is down and one is up, so n goes as 0 plus or minus 1 plus or minus 2 and so on, and the strength of the delta function is 1. Okay, so magnitude is 1, so here you have minus 1, here you have plus 1, so therefore it goes like that. Now, the amplitudes in the Fourier expansion of f of t are what? So, they are asked to find the amplitudes in the Fourier expansion. And this is the Fourier series in the complex form. Okay, so how do you go about finding the amplitude? So this is the formula for the coefficients in the Fourier series in the complex form. So we have 1 by the time period, and now here we substitute our values. Your t, the time period, you can see the time period is nothing but 2. Okay, so you can see the difference. Okay, so between this point and this point you can see the time period is 2. Okay, so between this point and this point 2. Okay, so value is 2, so t is equal to 2. So therefore if I substitute t is equal to 2 in this case, this equation will become no. F of t from the question is nothing but we are given that the strength of the delta function. So the spikes are at this is where the spikes are located. So I have to write a delta function of this form wherever the spike is located. So t minus a is a delta function, and a is this term. Okay, so this notation is confusing actually. Okay, let me say. Okay, so the spike. Okay, so wherever the spike is located, that point will be a. Okay, so that point will be a. So the delta. So f of t. So n is going from minus infinity to plus infinity, and t minus 2n minus 1 divided by 2. So just for simplicity's sake, let us take the calculation between t minus half to t is equal to half. So then an becomes half. So this is your integral. Okay, so this is your integral. So now this should remind you that for the integration of the delta function x minus a with respect to f of x dx now f of x dx will give you the value of the, now this will just give you f of a, that is the value of the function at where the delta function has a spike. Okay, so therefore this expression, now you just put where will the delta function have a spike here, it will have a spike at t is equal to, so in the first case it will have a spike at t is equal to plus half, and the second case it will have a spike at t is equal to minus half. So just put that and substitute t, so just put that and you will get the value of the, in the exponentials also you have to substitute the corresponding value of t, and that will give you your answer. Okay, so this will just be, so, so you should get, so the half is from outside the integral, and we have minus e. So just in the exponential term, just put the value of where the delta function has a spike. So this is t is equal to half, so I just put half here. And another 2, so here time period t is equal to 2, so just substitute that. So this becomes again, this is multiplied by minus half and the time period. So check that this simplifies to, now this can be written as, so this is your answer. So the right option here is given by the option C.